Which of the following functions represent SHM? So here first is sine square omega t. Let's say y is equals to sine square omega t, and we have to find whether this equation is SHM or not. First, differentiate y with respect to t, that is dy by dt, which is equals to sine square omega t 2 sine omega t into 2 sin omega t into sin omega t का डिफ्रेंसिएशन cos omega t into omega t का डिफ्रेंसिएशन omega. Alright, so dy by dt comes out to be 2 omega sin omega t cos omega t. It can also be written as omega 2 sin theta cos theta sin 2 theta, that is omega sine of 2 omega t. Okay, now d2y by dt2, again differentiating with respect to time. Omega is constant, sine 2 omega is cos of 2 omega t, and 2 omega t differentiation 2 omega. So here we will get 2 omega square cos of 2 omega t. Okay, 2 omega square cos of 2 omega t. Alright, now d2y upon dt2 is equals to 2 omega square cos of 2 omega t. Cos of 2 theta is cos square theta minus sin square theta. Let's see a trigonometric identity. Cos of 2 theta is cos square theta minus sin square theta. Now we can write cos square theta as sin square theta plus cos square theta is equals to 1. So cos square theta can be written as 1 minus sin square theta and minus sin square theta, that is 1 minus 2 sin square theta. So cos theta can be written as 1 minus 2 sin square theta. Here we are doing the same thing. 2 omega square will remain as it is, 2 omega square, but cos 2 theta is written as 1 minus 2 sin square, and here theta is nothing but omega t. Okay, sorry, 2 omega t. Cos 2 omega t can be written as 1 minus 2 sin square theta sin square into omega into t. Okay, so d2y upon dt2 is written as 2 omega square times 1 minus 2, and sin square omega t is equal to 1. Why? Sin square omega t is equals to y. So we have d2y by dt2 as 2 omega square into 1 minus 2y. बच्चों यहाँ से आप ये देख सकते हो कि d2y by dt2 is directly proportional to minus का y, and is directly proportional to minus y. That means this equation is nothing but simple harmonic motion. This equation is simple harmonic motion. This expression is differential equation for SHM. When d2y by dt2, that is acceleration, is directly proportional to minus y. Alright, so this first one is as an equation of SHM. Now come to second. Second is sine 2 omega t. So y is equals to sine of 2 omega t. Again differentiating with respect to time, dy by dt is sine 2 omega t will be cos of 2 omega t, sin theta differentiation will be cos theta into 2 omega t differentiation 2 omega. So 2 omega cos of 2 omega t. Okay, again differentiating, that is d2y by dt2, which is equals to 2 omega cos 2 omega t is minus sine of 2 omega t into 2 omega. So d2y by dt2 is equals to 2 omega, that is 4 omega square, minus will minus 4 omega square sine of 2 omega t, minus 4 omega square sine of 2 omega t, and sine of 2 omega t is equal to y. So d2y by dt2 is equals to minus 4 omega square into y, minus 4 omega square into y. Again d2y by dt2 is proportional to minus y. So this is also the equation of SHM. It is also an equation of SHM. Again, come to the third one, that is y is equals to sine omega t. Third one is y equals to sine omega t plus 2 cos omega t. So y equals to sine omega t plus 2 cos omega t. Differentiating with respect to time, dy by dt is equal sin omega t is cos omega t into omega t का डिफ्रेंसिएशन ओमेगा प्लस 2 cos omega t का डिफ्रेंसिएशन माइनस sin omega t into omega t का डिफ्रेंसिएशन ओमेगा. dy by dt comes out to be ओमेगा cos omega t minus का 2 omega sin omega t. Again differentiating with respect to time, that is dt2y by dt will be omega cos omega t will be minus का sin omega t. Omega t differentiation comes out to be omega minus का 2 omega sin omega t is cos omega t into differentiation of omega t omega. So here d2y by dt2 d2y by dt2 is minus omega square sin of omega t minus का 2 omega square cos of omega t. Alright, can we take omega square minus and omega square as common? Yes. Taking minus omega square as common, we get sin omega t plus 2 cos omega t. And here also y is sin omega t plus 2 cos omega t. We can replace dt2y by dt2 is equals to minus omega square, and replacing this sin omega t plus 2 by y, we get d2y by dt2 proportional to minus y. Again, it's an equation of SHM. It's an equation of SHM. So third expression is also an equation of SHM. Now fourth one is y is equals to sin omega t plus cos of 2 omega t. Okay, differentiating with respect to time, dy by dt is sin omega t comes out to be cos omega t into omega plus cos 2 omega t is minus का sin 2 omega t into 2 omega. dy by dt is equals to omega cos omega t minus का 2 omega sin 2 omega t. Again differentiating with respect to time, d2y by dt2 is equals to omega cos omega t is minus sin omega t into omega minus का 2 omega sin 2 omega t is cos 2 omega into omega. Okay, here d2y by dt2 is equals to minus omega square sin omega t minus 2 to the 4 omega square cos of 2 omega t. Okay, and d2y by dt2 is equals to, taking omega square as common and minus also common, minus omega square, this will be sin omega t, and this is plus 2 cos of 2 omega t. बच्चों y की वैल्यू है sin ओमेगा t प्लस 2 cos 2 ओमेगा t. यहाँ d2 by dt2 sin ओमेगा t प्लस 2 cos 2 ओमेगा t. 2 cos 2 omega t, it is 2 cos 2, or sorry, not 2 cos 2 omega t, 4 cos 2 omega t. Okay, here it is 4, so 4 cos 2 omega t. Now since it d2y upon dt2 is not proportional to minus y, not proportional to, okay, this is not proportional to minus y, because it is sin omega t plus 4 cos 2 omega t, 4 cos 2 omega t. Here it is sin omega t plus cos 2 omega t. So d2y by dt2 is not proportional to minus y. Again, it is not an equation of SHM. So this is not an equation of SHM. If it is not SHM, can it be oscillatory motion? Yes. Sin omega t and this is cos 2 omega t, both are periodic function, both are periodic function. They will oscillate about their mean position. So this is oscillatory motion but not SHM. Also, we can see that this equation have two frequencies. One is omega and again another one is 2 omega. But what we have seen, x is equals to a sine omega t plus minus phi. So their frequency is only one, not two. For linear SHM, there is only one frequency. Here the frequency is omega as well as 2 omega. Okay, both functions have two different angular frequency. So basically this is superposition of SHM of two different frequency. Okay, it is not an equation of SHM, it is oscillatory motion. It is oscillatory motion. It is oscillatory motion. So the final answer is not an equation of SHM because it is not proportional to minus y, but it's an oscillatory motion as sin omega t and cos 2 omega t both are periodic functions. Alright students.